There's a chemical that they require for gas, think of them as the fuel, called NAD. And there's another molecule that is like the accelerator on the enzymes that makes them go even faster, and that's one of them is called Resveratrol, which we discovered years ago from red wine. And together they actually do really great things on these enzymes and make them keep the body younger at least.
Here are the results for the level of NMN found in various tissues, 1, 2, 4, and 6 hours after the administration. One thing that does seem clear is that NMN is getting into the tissues, and so presumably not all being broken down into nicotinamide in the liver. NMN on its own has the biggest impact on the liver. In the heart, resveratrol increases NMN presence by 1.39 times. Whereas ginsenoside increases NMN in the brain, heart, kidney, and lung by 4.14, 2.31, 4.47, and 2.39 times respectively. They also looked at the levels of nicotinamide riboside, or NR, as they proposed that the NMN was converted to NR before being transported into the cells and then converted back to NMN. In this case, only the heart tissue, with an increase of 1.93, showed a significant change when combined with resveratrol, while ginsenoside helped in the liver and kidney. But probably the most important is the NAD levels in the tissues. Here, NMN on its own had a significant impact on the liver and kidney, suggesting that supplementation with NMN will help energy metabolism in those tissues. When combined with resveratrol, the impact on the heart and skeletal muscle was increased by 1.59 and 1.72 times respectively, while ginsenoside increased NAD levels in the lung by 1.97 times more than with NMN alone. So we saw that combining resveratrol with NMN increased the NAD levels in the heart and skeletal muscle, while when combined with ginsenoside, it increased the NAD in the lung tissue. I would also add that oral NMN was shown to increase NAD in the liver and kidney. Great to see tissue-specific breakdown of NAD levels after taking oral NMN, even if the dose was high, around 3 grams for a 75 kilogram person by my calculations, and super interesting to see the impact of resveratrol and the ginsenosides on the NMN absorption. They also looked at NMN with exercise. The exercises were aerobic for 40 to 60 minutes, 3 times a week, with an increase in intensity after 2 weeks. The paper refers to aerobic exercise, but the methods section also mentions resistance training 3 times a week with no further detail. There were 42 participants in a placebo and 500 milligram group. At the end of the study, the placebo group had NAD levels of 33.1 micromoles, and the 500 milligram group at 55.48. This is in comparison to 23.8 and 41.7 respectively for the same groups in the no exercise study. So taking NMN raised NAD in addition to the level gained through exercise.
And then also other athletes that I've talked to have reported the same thing. So increased endurance and faster recovery times, because NAD is also essential for inflammation. So it does regulate inflammation, and especially the combination of NMN and quercetin can do wonders for your athletic recovery. This is what we're seeing, again, anecdotal evidence from our customers.
To raise NAD levels, what we've done in my lab to mice for the last decade is we give them precursors to NAD. So we give them molecules like nicotinamide riboside, or NR, or nicotinamide mononucleotide, also known as NMN, not to be confused with M&Ms, which will have the opposite effect. And so NMN is what I take each day. I take a gram of it. But the thing with nicotinamide mononucleotide NMN is that it has this nicotinamide group on it. It hangs off the main part of the chemical, and it's the first bond to break. And so we see in animals and even in humans that the levels of nicotinamide go up quite rapidly after taking NMN or NR. And too high levels of nicotinamide are not good, in part because the nicotinamide gets excreted through the kidneys, and it's done so, that happens because it becomes methylated into methyl nicotinamide. And methyl nicotinamide has been used for years as a marker of all sorts of things, including at least experimentally for Parkinson's disease. But the concern that's being talked about in social media especially is this drain of methyl nicotinamide a problem? The methyl groups are needed for the body. We need methyl for a whole range of things, including antioxidants. And so as a precaution, I take trimethylglycine so that I continue to give my body a source of methyl groups. Now, I don't know if that's true. People ask me all the time. I take it as a precaution because I know that trimethylglycine is not going to hurt me. Glycine is good, as you mentioned, Joe. And the other thing is trimethylglycine is also known as betaine, which on human cells is very good for them, including protecting them against stress. So I don't see any downside. It's not an expensive molecule. And the upside is that I'm preventing my body from being drained of methyl groups. So I do take it as a precaution, knowing that it's probably not doing anything except goodness.
What happens is our cells are using more NAD than they can make or recycle. It means there's a deficit. And the repair and maintenance processes down here in the cell that are actually dependent on NAD, they have to fight over a limited supply of NAD. This ultimately leads to damage and then to some signs and symptoms of aging. If we go back to the little diagram here, what happens if you just use a supplement such as NR or NMN, a precursor-based supplement? The precursor goes into the cell. It does get converted into NAD, which is why you see companies that produce these molecules show around a 60% increase in NAD boost with these supplements. So you do get an increase in NAD, but this NAD is then used up and it's broken down. And as soon as it's broken down, it's converted into nicotinamide. And if you haven't fixed the underlying problems in the cell, which are causing NAD to decline, namely this reduction in the salvage pathway because of this enzyme that's declined with age, what happens is the cell has to get rid of it. So it methylates it and it excretes it. Then if you just continue pumping more NR or more NMN into the system without trying to fix the salvage pathway, you just keep contributing to the problem because your cells are using up this initial boost of NAD, but it's getting converted into nicotinamide. And then the nicotinamide has to get out of the cell. So you get methyl donor depletion. And this is why many practitioners will say to the clients, you need to use trimethylglycine or something like that to actually stop these negative effects, because a depletion in methyl groups is actually really bad for epigenetics because it's very important for altering the structure of your DNA.
One of these internal antioxidants that resveratrol increase is glutathione. And to make glutathione after the activation by resveratrol, our body needs amino acid called glycine. And collagen is the food with the highest levels of glycine on the planet. This suggests another synergy between collagen and resveratrol. Glycine, by the way, actually improves longevity on its own. So by integrating collagen into our lifestyle, or at least taking more glycine, we have a good chance to create a resveratrol synergy and make resveratrol more effective. Another amino acid that supports our natural antioxidant defense system is cysteine. The name of cysteine supplement is called NAC, N-acetylcysteine. Collagen doesn't have it. It's a different supplement. And similar to glycine, cysteine also helps the body to make glutathione. And this supports potentially the activity of resveratrol that tells the genes to make more glutathione, and then glycine and NAC supplying the building blocks to the genes to make this glutathione. It looks like a very good case for a synergetic effect, and in fact it seems that glycine and NAC have a synergetic effect between the two of them. I'm quoting from this 2022 study. So this is what they did in the study. Evaluating the effect of supplementing of glycine and N-acetylcysteine versus placebo in mice, and compare that with the length of life and age-associated glutathione deficiency. Results show that mice receiving this glycine and acetylcysteine supplementation lived 24% longer than control mice. By correcting glutathione deficiency, oxidative stress, mitochondrial dysfunction, abnormalities in mitophagy, and nutrient sensing and genomic damage. All these are excellent for our longevity. However, what happens when you take resveratrol and you have resveratrol in your blood when you're exercising? In this situation, I would assume it's going to minimize a lot of the benefits of resveratrol. I'm going to explain what to do in a minute, but let's go over the studies and analyze them. So this study says that all subjects perform 8 weeks of high-intensity interval training, cycling twice a week. In addition, subjects conducted a timed 5 kilometers walk once a week. So as you can see, this is a cardiovascular activity. You get a large amount of oxygen in a short amount of time. You don't want resveratrol in the blood when you do those activities. Let's see what happens in the second study. High-intensity interval spinning training twice per week, in addition to 5 kilometers walk once per week. Again, we see it's a cardiovascular activity. And the results show that resveratrol negates some of the benefits of exercise.
If we gave it to mice their whole lifespan, they were protected against a high-fat diet, which we call the Western diet. They had lean organs. They lived slightly longer, but not a lot. This is what's not known, though it's in the supplemental data of the paper that nobody ever reads. The mice that were given resveratrol every second day on a normal diet lived dramatically longer than any other group. So people out there, my critics say, oh, resveratrol didn't extend the lifespan of mice on a normal diet, therefore it's not aging, it's just protecting against a high-fat diet. Well, look at the supplemental data, please. If you give it to the mice every other day, we had mice living over 3 years. And what that told me is that probably you don't want to be taking a supplement every day. You can take it either every other day or give your body a rest.
And what I do with resveratrol. And resveratrol, taken correctly, is a wonderful anti-aging usefulness preservation supplement. Now, what do? Personally, I take about 1 gram every other day, always with fat, never before exercise, always after exercise. And sometimes I take it with a sip of alcohol, which possibly can improve the absorption as well of resveratrol. The thing is, I don't want resveratrol in my blood and in my muscles when I exercise, because I want the stress from the oxygen. I don't want anything to negate that stress. So
Yeah, that's an excellent point. So, in order to build muscle, okay, to increase muscle mass, you need to activate the mTOR pathways, okay? And as Matt Kaberlein told you before, we want mTOR pathway to be down, okay, with aging. So there were studies that took elderly people, exercised them, and half of them were on metformin. And actually, the grant for this study and the hypothesis was that they'll be synergistic to each other. Okay, they'll add to each other. And what the researcher found, it's not only one group, it's a couple of groups, and they showed that when you exercise, muscle increase, okay, for all of them, but less so with metformin, okay? Now, hidden in the paper, in supplement 4, is the most important data that, yes, the muscle was smaller, but the function of the muscle, their strength was the same. So explain to me, if the muscle strength is the same, it means that this little muscle, for every gram of this muscle, it does better than the gram of muscle itself. So we took, like the study I told you before that was only on metformin, we took the transcript from this group that published this paper, and we showed really 2 things. A, that the transcripts that are mTOR related were decreased, okay, and that's why the muscle didn't grow as much. But on the other hand, genes that are associated with the other hallmarks of aging, like for autophagy or inflammation or other things, have been changed and been more youthful. So there is a trade-off. So I always say, if it's important for you to show your muscle, don't take metformin. But if you're concerned with aging, I think it's good. You still get the benefit of exercise and the muscle. But also, look, I think what's missed in all that, I think the muscle, how the muscle looks like is not the strength of metformin. But remember, muscle is one organ, and metformin has all those other effects, right? On heart and on brain, on other things. So you have to look at it at all. And there might be trade-off, but I don't think the trade-offs are so big. Metformin is going to be great for the whole body, and metformin is not bad for the muscle, okay? The muscle function is the same.
So I think this is, the perspective that I'm caring about it, and at least it's my data. I can claim that I believe in it because I studied it. If you're young, you don't need metformin. Build your muscle. It might pay well for the future, right? And if you're older, then you have to think of metformin's all effects and the fact that maybe the muscle is not going to be so big, but it's going to have a good quality, and that's the trade-off.
You mentioned in particular rapamycin plus metformin. We actually did test that, and the results were a little hard to interpret. Metformin by itself has no effect on mouse lifespan, no benefit, at least at the dose we tested. It's possible that at some other dose it might have been good, but at the dose we tested, it had no benefit by itself. Now, when you combine it with metformin, with rapamycin, so you have metformin plus rapamycin, it gave a slightly increased lifespan in the males, but it was not statistically significant. So we can't say, look, we've got strong evidence that the two put together do better than rapamycin by itself. There's a sort of a hint that that might be correct, but it didn't rise to the standards expected for strong conclusions, so we published it and people can draw their own conclusion. We've also evaluated rapamycin starting at old age with different dosage regimes. In the experiment, which was just published, some of the mice got rapamycin starting at 20 months of age and then for the rest of their lives. And in both sexes, you got a benefit, exactly the way we would predict. Others of them got rapamycin in an on-off, on-off. So they got it for 1 month on, 1 month off, 1 month on, 1 month off. For males, this cycling thing worked great. It was just as good as having it every single day. For females, it was about half as good. It worked, but it wasn't as good as leaving the stuff in there all the time. And the third dosage regime was we gave it to the mice when they were 20 months of age for just 2 months, and then we took them off. We gave them a hit, a pulse. For males, it worked great. It was just as good, but for females, it only works half as well.
Okay.
We don't know why, and it would be nice to know.
I would love to know. Right.
It may well be different in mice, in humans, in dogs. These are likely to be molded by sex-specific enzymes and sex-specific excretory pathways that are probably going to be quite different from in every species. We're just about to submit a paper in which we've combined 2 drugs, rapamycin plus Acarbose, and that gives us the best percentage increase in males we've ever seen. We're getting about a 29% increase in males. Acarbose did not improve on rapamycin effect in females. So this is a combination of drugs that is working better in the male mice than in the female mice, even though rapamycin by itself tends to give a greater numerical effect in female mice than in males.
I'm not particularly concerned about causing toxicity or having adverse outcomes. I just think they may cancel each other out with respect to aging, because that's what we see in mice. And so let me give you an example theoretically of what might happen. So you have rapamycin, it turns down TOR signaling, and then you add another molecule, maybe AKG, and it turns TOR signaling down even more. And now it's too low, as opposed to you need to have that pathway on at certain times as well. And so if it's too low, then you're maybe doing bad things, right? So until we know more mechanistically about what these things are doing, I think it's hard to predict how they're going to combine and whether it's going to be additive or they'll cancel each other out. So, but you're right, natural products tend to be safer. That doesn't mean they're completely safe. If you give too much vitamin A to a mice, it's not good for them, and I have data to prove it. But in general, they're safer because their body's used to using them. And so if you look at something like AKG or NAD, that gets consumed really fast. A lot of drugs become toxic because they build up in the body, and you start getting higher and higher doses over time, and that can do things you don't want them to do. It's hard to imagine getting too much AKG because it's used up so fast in chemical reactions. And so the benefit of these molecules is probably the reactions that they drive, not the levels that accumulate in the body. And of course, when it comes to drugs, you've got things that the body hasn't seen before, and you have more unexpected outcomes. Now, notice I didn't say that natural products are completely safe because that's not true. But most of the molecules that are on the market that come from the aging research field, I think that are pretty safe right now. I mean, the NAD precursors, we haven't seen a lot of adverse events or anything from that. The AKG, there's a lot of data on, and some of the other molecules that are out there. So it's a little bit Wild West right now. And like I said, I don't mind that as long as the people making these products are sure that they're not taking a big risk with individuals.
Let me quote from this study. Metformin inhibits the tumor-promoting effect of low-dose resveratrol and enhances the anti-tumor activity of high-dose resveratrol by increasing its reducibility in triple-negative breast cancer. Please don't get scared by the headline of this study. Resveratrol doesn't cause cancer. They already started the study with an active tumor. They found that in an active cancer, whereas low concentration of resveratrol was not helpful, high concentration of resveratrol inhibited cell growth and induced both autophagy and apoptosis. And the study even showed a synergy between high-dose resveratrol and metformin. I'm reading from the study. Metformin combined with resveratrol exerts a synergetic therapeutic effect on cancer cells and effectively prevents tumor progression. When you go up in the dose, suddenly high resveratrol makes metformin more potent against cancer. Now, if you've been with me in this investigation from previous videos, this is not surprising for you as well. We have seen in our investigation that high-dose resveratrol works completely different from low-dose resveratrol, and high-dose resveratrol has a very strong anti-cancer effect, forcing cancer cells to die.